Welcome to ECLM Learning Simplified. My name is Ruth, and today we are going to be doing the last bit of alkanes. So we are going to be tackling the chemical properties of alkanes and then also look at uses of alkanes. And then we are going to end the subtopic on alkanes. So first of all, some of the chemical properties of alkanes is the burning of alkanes in air. So alkanes usually burn in air in a pale blue luminous flame. So it is important to remember the color of the flame because this is going to apply to our paper 3 when we get to qualitative analysis. So they usually burn in air with a blue flame, pale blue flame. Remember they are saturated. So to give carbon dioxide and water. So this is the equation, for example, for burning methane in oxygen to form carbon dioxide and water. So in a limited supply of air, it usually forms a luminous flame because it doesn't burn completely. So this is due to the incomplete combustion of methane. A mixture of methane and air explodes violently when ignited if the volume ratio is approximately 1:10, and this often causes fatal explosion in coal mines. So the next property is the reaction of bromine water and acidified potassium permanganate. First of all, when you bubble methane through bromine water, the red-brown color of bromine persists. It means it doesn't change. The same case with the purple acidified potassium permanganate. The purple color does not turn into colorless. This is because the alkene does not have, that is in the case methane does not have any effect on the bromine water or potassium permanganate. This reason is because it's a saturated hydrocarbon. So this tells us that when it comes to unsaturated hydrocarbons, it's going to change. The purple, potassium permanganate 7 and bromine water, their colors are going to change. So this is actually one of the chemical processes that helps us to distinguish between saturated hydrocarbons and unsaturated hydrocarbons. So another process is a substitution reaction. So substitution reaction is when one of the atom replaces another atom in a molecule. An example of substitution reaction is a reaction of bromine with methane. Yes, initially we say that it does not decolorize, but this reaction can actually occur, but in presence of sunlight. So a small methane is placed in a boiling tube and some bromine gas are bubbled into it. The tube is stoppered and the mixer shaken, and then it's allowed to stand and exposed to a ultraviolet lamp. So one of the observations you notice is that the red color of bromine gas is going to fade and a pungent smell of hydrogen bromide gas is going to be detected when the stopper is removed. So hydrogen bromide turns blue litmus paper to red. So that is the equation. But what is exactly is happening? So we initially said that bromine does not react with methane, but now we are saying that methane is reacting with bromine under special conditions of the UV. Why is that possible? So for a chemical reaction to occur, both must be broken, just like we will say when we come to thermochemistry. So the ultraviolet rays or the ultraviolet light that comes from the UV lamp causes the bromine molecule to split. Remember, bromine is bonded to another bromine by strong covalent bond. So this bond causes the bromine atoms to be broken to form free atoms, which are very reactive. The same energy from the light is usually helps to break the carbon hydrogen bond. So now we have some bromine atoms and carbon hydrogen bonds that have been broken. So after the free bromine atoms can now react and replace the hydrogen atoms in the methane, resulting to a formation of bromomethane and hydrogen bromide. So the process can be repeated until all the hydrogen atoms in methane are replaced. Substitution reaction can occur with bromine, with chlorine as well, forming chloromethane, with dichloromethane, trichloromethane, and tetrachloromethane. So the product that we get depends on the concentrations of the reactants and the product. If the concentration of the reactant is higher than the concentration, let's say for example, of the alkene is higher than the one of the halogen, definitely we are going to form the first product. But if the halogen is in excess, it means it's going to form the final product. All the hydrogens are going to be replaced. If the equation is 1:1 or the concentration is 1:1, it's going to form just one replacement. So note that if it's in excess, or everything is going to be replaced, that is if the halogen is in excess. But if their concentrations are equal, we're only going to form the first product. So let's look at an example. So the reaction of methane with bromine gas. So it's going to be CH4 plus bromine. So bromine is going to be replaced. We can open it up or we just condense it to form bromine and hydrogen bromide. So this can go on and on and on. So this second product can react with more bromine to form a dibromo methane, which can further react with more bromine to form tribromo methane, and which further can react with more bromine to form tetrabromo methane. So this the last, it occurs when the bromine gas is in excess. So we can also do the reaction of methane with chlorine, but now only the first step. So only one hydrogen is going to be replaced. We can show that in the first step. To form hydrogen chloride. So this reaction can go on and on and on until all the hydrogens are replaced, and then also the reaction of methane with chlorine. So CH4 plus Cl2 to form CH3 Cl plus HCl. So some of the uses of alkanes, so be as specific as possible, do not use general terms. So most alkanes are actually used as fuel. For example, methane is used as biogas in homes, and butane is used as a laboratory gas. So also alkanes are actually, cracking of alkanes is one of the sources of hydrogen in the manufacture of ammonia in Haber process. And then methane is also used in the manufacture of carbon black, which is a component in printers of ink. Methane is also used in the manufacture of chemicals like methanol, methanol, and chloromethane. So you notice how methane is used quite widely. So let's do one question or two in regards to what we have discussed. So the setup below was used to investigate the products of burning biogas or burning methane, study it and answer the questions that follow. So what product would be formed as test tube Y? State and explain the observations which are made in Z. So first of all, biogas is a product of hydrogen and carbon. So when you burn it, you produce carbon dioxide and water. So the water is the one that is formed and cools on the ice cold test tube. And then carbon dioxide is absorbed by calcium hydroxide to form a white precipitate. So the first question, the product formed in test tube Y is going to be water. And then the second question, state and explain the observation made in test tube Z. So calcium hydroxide is going to turn into a white precipitate because it forms calcium carbonate when reacted with carbon dioxide. Then in the presence of UV light, ethane gas undergoes substitution reaction with chlorine. What is meant by the term substitution? So this is a reaction where one atom is replaced by another atom in a molecule. Give the structural formula and the name of the organic product formed when equal volumes of ethane and chlorine react together. So we said when we have equal amounts, you get only the first product. So we are only going to replace one. So the structure, remember the question is on the structure. So we'll put that. And the name will be 1-chloroethane. If it was in excess, you'd form the final product. So we do one last question. Study the flowchart below and answer the questions that follow. What name is given the type of halogenation or chlorination in step 2? So we had done this question before. So remember we said this was methane. So methane reacts with chlorine presence of ultraviolet. So the step is called substitution reaction. That brings us to the end. So we are done with alkanes. So in the next session, we are going to be looking at alkanes. So see you in the next lesson.